this form of the XY, being, the basic coordinates of the two-dimensional plane, the three-dimensional becomes a vertical line outside of, or rather different. So now we have three lengths, and you can go up to the side or down, or up, down, and to the side, which ultimately just means there is an extension of something, and in that extension there's a discrete measure of it, like there are like points, or like as we have in basic geometry, a point is only one dimensional and it extends outside of itself while still maintaining itself, and that becomes a line. So it's just stretched. A point is just stretched, and now that stretch itself develops length, and so it becomes wide, and it becomes wide, and then when it becomes wide, now we have squarish plane. The figure itself is its own plane, and that thing now extends three-dimensionally outwards, and it becomes this cube. And ultimately this cube is three-dimensional because it has the diameters stretched as the sides of a figure. And you're literally within this dimensional framework. And in this framework, there's at least all these three dimensions interplaying at an interplay with one another. They are themselves based on the observer, the conception of them maintaining each as different from the other, while yet necessarily supplementing the other to be itself indifferent from the source from which it's taken to be not identical with itself. And so their very difference is ultimately the unity that makes them different. When this cube, this three-dimensional cube, becomes four-dimensional, now we have a more realistic description and observation of the dimension we're maneuvering with it. And this dimension is a tesseract shape. You see, the tesseract shape is ultimately a cube within a smaller cube. The bigger cube is within the smaller cube. Now think about what that means. Because we think, well, the smaller cube must be within a bigger cube, because the length of the bigger cube is bigger and another one is shorter. We can fit the smaller within the measures of the bigger. But then simultaneously in doing that, the bigger contains the smaller. And therefore the smaller, now being literally identical with the bigger, is also at every length within it, you see? It's not like just one cube out into the distance, but now it's on the side of the square or of the cube, the side of this, on the left and on the right and down and in and out, and it's constantly become this cube, or rather these multi-cubes constituting each side of the cube. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The 6 sides of a cube. Each are disclosed within a cube, or rather disclose a cube, that the sides of the square at a two-dimensional state ultimately is identical to the length that makes up the sides of the cube. And so